Hello, I continue my series on repairing a surface grinding machine. Much has been done to date. For new viewers who haven't seen the previous episode,
I'll briefly note that the X-axis guides, 3 meters long, have already been brought to a geometrically correct state through scraping. This material, i.e. the work done, is shown in previous videos, from video number 24 up to this one. These X-axis guides are now, conditionally, within the project's relevant dimensions, absolutely straight and parallel to each other, with a straightness error of less than 10 microns, 0.00039 inches, and a parallelism error of less than 5 microns, 0.0002 inches. A key factor in this geometry repair was using an autocollimator as a straightness control tool, enabling scraping with the specified precision. This extensive work, their restoration, I consider a fascinating story worthy of close attention, a thrilling adventure dealing with both large and very small dimensions simultaneously, with many specific, interesting circumstances, and a successful outcome. I'm satisfied with the current state of these surfaces, they are precise and thus beautiful. The cutter marks created a spotted pattern on the working surfaces, which glimmers vividly under lighting. This type of surface provides the best conditions for machine operation and durability of the guide friction pair. Now, it's time to advance the repair further. This is the machine's table, flipped with its guides facing up. These guides now need work. Today, we'll closely examine the next step in the machine repair, fitting the table guides to the already straight bed guides. For clarity, I've prepared an animation. This is a great opportunity to convey the essence of the information more effectively, especially when the animation is based on real work and footage, as in this video and others I've made. Thanks to digital technology. Here's a virtual model of this machine under repair. The bed guides have been scraped and are now straight. The table moves along the X-axis guides. Its interacting guides are worn and don't properly contact the repaired bed guides. Using scraping based on paint marks, I'll eliminate this mismatch to achieve full mutual contact of the interacting surfaces. However, a key aspect of this process must be understood: the bed guides are part of a massive cast iron frame, reinforced by a specially built reinforced concrete foundation per the manufacturer's requirements, and rigidly secured with 12 powerful anchors through corresponding mounting holes in the bed base. This makes the bed guides, further supported by the foundation, extremely robust and highly resistant to elastic deformation under working loads. Their geometry is now precise, deformation-resistant, and thus very stable. Conversely, the table is a long, flat component, highly prone to deformation. When we place the table on the bed guides, its support guides, not yet geometrically correct, not only lack full contact with the interacting surfaces but also experience some twisting upon resting on the bed guides. This twisting results from the table guide surfaces not yet being properly aligned. In scraping the table guide surfaces, I must not only ensure full contact of the interacting surfaces but also eliminate any twisting stress in the table itself. This goal is achieved only through specific technological measures to monitor the table's twisting condition. The first thing I need now is to position the table so it fully balances its internal stresses, free of twisting loads. Then, using a precision level, I can lock in this untwisted state. Ideally, this would be solved by sending the table into orbit, in zero gravity, where twisting would vanish entirely. But in orbit, a bubble level won't work, so another solution is needed. The best I've devised so far is this: I suspend the table from a single support point, finding its center of mass by adjusting this point until the table balances and stabilizes fully. I then bring heavy, stable supports close to it, positioning them with minimal gaps to the table but no contact. The table remains independent of the supports for now. I fill the gaps with liquid epoxy glue, preferably shrink-free. Once the glue hardens, the table is fixed in an untwisted state. Now I can prepare two control pads at opposite ends of the table, created by scraping. Using precision level measurements, I bring these pads into a parallel state. With them in place and parallel, I can monitor the table's condition when placed on the bed guides, detecting any propeller-like twisting or its absence. I'll understand whether the table is twisted, how much, and in which direction, allowing precise adjustments during the repair process. Thus, during scraping, I can adjust the material removal from the table guide surfaces, not just by paint marks but also by factoring in twisting measurements, applying more force where needed until the table rests on the bed guides without twisting, achieving full, evenly distributed contact with the bed guides. This ensures complete mating of the table's working surfaces to the bed guides without twisting stresses in the table. It creates an optimal guide geometry, evenly distributing loads across the entire contact surface between the bed and table guides. This condition ensures the best interaction, with evenly distributed specific loads across the working surfaces, minimizing wear rates of the friction pair in this linear motion system. Only by meeting these conditions can I truly fit the table guides to the bed guides effectively. Once this fitting is complete, I can move on to further steps toward finishing the repair. Since I've outlined the key aspects of this procedure using animation, and I hope it's clear, I'll now back it up with real footage of the work performed. Theory stems from practice and exists for it. My theoretical material will be complete once you see how this happens with real machine parts, their actual deformations, and the loads causing them. I made these support trestles for working with the table. The workshop has a crane that facilitated table handling. I crafted tools for flipping the table. You can now see how clogged the inner surfaces around the table guides and the guides themselves are, a legacy of years of prior use. Now I need to disassemble these guides, clean, and wash everything. The table guides are not integral to the table, they're attached. Beneath them are channels for a protective rubber and fabric strip. I unscrew numerous bolts and disassemble it to remove oily dust buildup. Fortunately, unlike car repairs, this machine's bolts and nuts unscrew easily despite being tightly fastened. Cleaning is essential, even mating surfaces have accumulated debris over decades. The oily deposits will be removed in a few hours, and I'll prepare for reassembly. I'll dismantle the second prismatic guide next. The entire table is disassembled, everything is terribly dirty, and a messy washing process awaits. You can clearly see how flat the table is, likely a cast iron section around 20 mm thick. I hope you now see, from the table's proportions, that the flexibility shown in the animation is real. The greasy dust layers are cleaned off using a vacuum, white spirit, brushes, and rags. The table is now ready for further processing. These parts and a steel ball will soon play a key role in reassembling the table and its guides. Now I'll use my flat stones, as seen in video number 4. The mating surfaces need additional grinding. The harsh sound of the stone rubbing indicates burrs. Once these are removed, the sound changes. Nearby, guys are spot welding something, creating annoying noise I'll try to dampen in editing, but it'll still interfere. Thanks for your patience with these conditions. Here's how the surface changes after grinding with a flat stone. We clearly see the relief created 54 years ago at a machine building plant in Lipetsk, Belarus. The sound softens and evens out as the stone moves. This surface is now ready to mate with the table guide's counter surface. All contact surfaces are corrected this way. The post-grinding surface image convincingly shows its condition. We see the machine's processing marks, step patterns, and slight waviness. Every elevation is visible, with burrs around holes smoothed out. The guide overlays are ground similarly. Once all surfaces are prepared, cleaned, and ground, I begin reassembling the table and its guides. While welders do their noisy work, I carefully and smoothly place the prismatic guide in position. Now I ensure full contact of the mating surfaces. I lightly screw in the bolts, but don't tighten them yet. The second, flat guide is prepared similarly. Its ground surface differs slightly. The machine that ground it was in poor condition, leaving a very wavy surface, but this poses no issue, they'll still mate tightly with bolts and work fine. I place this guide just as carefully. All surfaces and my clothes are vacuumed clean. The surfaces must mate without interference. These movements aid full contact. If a dust particle slips in, it'll be crushed and expelled. I use one conical pin, the second requires a new hole drilled and reamed after tightening the bolts, as this is a fresh assembly. I insert the bolts, preparing to tighten them. I've said I screw in the bolts but don't tighten them fully. After full insertion, I turn them back half a turn. Here's why. This free suspension, a pivot, relieves the table of twisting stress when I tighten the guide bolts. One of the 3 support points will rest on this ball, providing enough mobility to prevent twisting stress on the table. A bit of oil lubricates the ball. The table now sits on 3 points, one a pivot. You can see how it deforms under slight twisting load while on this pivot suspension. I place a hammer on the right, the bubble shifts left. On the left, it shifts right. Knowing one scale division is 20 microns per meter, with a 30 centimeters lever, the hammer twists the table, lowering its point by about 5 microns. Now, with the table nearly untwisted on the pivot, I tighten the guide bolts. This is done like tightening a car engine head, following a pattern, either edge to center or center to edges, diagonally. I aim to lock this assembly with minimal internal stress. I apply minimal pressure to the wrench, focusing on torque. With cleaning and guide reassembly done, I'll make an initial scraping pass to level the guide surfaces. Then I'll flip the table and create parallel control pads on opposite ends. In reality, I did this slightly simpler than in the animation. I hadn't yet thought of suspending the table from one point. Instead, I used 2 rigid supports and 1 pivot. The level pad was scraped, and its position marked. The pivot suspension is at the table's center, fixed in the T-slot. By rocking the suspension, I relieve all twisting stress from the 3 support points. I've already made a second support pad on the opposite side, attaching a ground steel plate since the slope was steep, and I didn't want to scrape too much. I compensated the slope with a shim of the right thickness, making the pads parallel. Footage confirms this suspension works. With the guides now tightly attached, the table is stiffer, and the bubble moves less than before, but it's still visible. The pads are ready, parallel, and marked for level placement. I'll also show how twisted this table was during its original machining. We can't know if it was like this initially or if stresses redistributed over time, but now its twist nears 1 mm at the edges, measurable with a basic construction level. Thus, I've prepared the table for scraping its guides and can now begin fitting them to the bed guides, which we'll do in the next episode. I've been repairing this machine for over a year without earning from it, spending not just time but also money on this project. This is tough, especially since I live in a country where war has raged for 4 years. Only support from some viewers via Patreon and sponsorship keeps me going. Thank you for your support. Thanks to you, I can do this fascinating work and release these videos. My channel is still too small to sustain me through monetization alone. Above all, like all Ukrainians, I'm grateful to those supporting Ukraine in these difficult times. In the next episode, we'll fit the table guides to the bed guides. Thanks for your attention, support, comments, and likes. Goodbye.